everybody. Good morning. Today is Friday, March 31st. And then today you have homework 7 and quiz 4. Okay, everybody? Don't forget to do your quiz. All right. So when is our exam? Next Friday. Yeah, you're Wednesday. Yeah, and you guys next Friday. And our review session is on Wednesday. Oh, I know why. Okay, I can give you my last semester's recording. For the review session. So you can watch the recording.
I'll be in class on the Wednesday that remember I was taking it on 12:45 after the fact.
But we're not doing the review in the class. We're doing the review at 8 p.m.
Oh.
So.
Yes, please.
Yeah. Could you email me to remind me? Yes. Okay. All right. So, yes. Okay. So, yeah, please take out a piece of paper. So we called last time, we talked about rational functions. Rational functions, we're going to have vertical asymptotes. So vertical asymptotes are the vertical lines that the graph of the function get closer to the line. Okay? And remember we have 4 ways because you can have left or right, and then you can have top or bottom. So we have 4 directions. Right, everybody? Do you remember that? Mm-hmm. And how do we solve examples? So the example will ask us to find the vertical asymptote. And then for each vertical asymptote, we need to determine what happens as x approaching to the vertical asymptote from the left and from the right. Do you remember that? Mm-hmm. So what were the steps? First step, factor. Everybody say factor. This keyword is really important because I do have students, I give them the factor form and they try to multiply out. No, we want to have the factor form. Okay? So that is the first step, factor. If it's not factor, then you gotta factor it, okay? Or if it's factor, then it's perfect. You can go to step 2. Step 2 is you set the denominator not equal to 0. Do we care about the numerator? No. Just the denominator cannot be 0. Okay? And you have, because you already factor it, you have a product of 2 factors not 0. So you set each factor not 0. Okay? And in this example, we get 2 numbers, -2 and 1/2. So for each number, you let x goes to that number from the right and from the left. Is that okay, everybody? So from the right, right-hand side is more positive. Okay? So the notation is x goes to -2 from the right. This arrow means goes to. Okay, what goes to means? Okay, you can think of, this is your x, right? And this is the number, let's say this is the 2. So x is right here. You let x goes to 2. So your x is getting closer to 2. Maybe here is 2.1, and here 2.05, here 2.01, here 2.001. So you have like a sequence of points getting closer to the 2. And then they want to figure out what happened to your y. If your y is getting bigger, that is infinity. Right, everybody? If your y is getting smaller, is negative, but the magnitude is also big. Okay? It's not small in the magnitude, but the number is big in the magnitude, but it's negative. Okay? Then the y will go to minus infinity. So this arrow goes to is really like a process. you're letting x to be closer, closer, closer to 2, right? But x is never equal to 2. It's like, okay, I'm getting closer, closer to you, right? But I cannot be him. I cannot get into him, right? So this is getting closer to it, but not equal. That's why what the arrow means. Arrow means getting closer, closer, closer to it. And then last time I also show you that 1 over 0 is not defined, right? But 1 over 0 plus is infinity. That's the top, right? That's the like heaven. And 1 over 0 minus is negative infinity. That's like right? So different. So that's why if your denominator is close to 0, and then it really make a big difference whether it's approaching 0 from the right or from the left. Okay, everybody? So that is why here you plug it, you got x goes to -2 from the right. And remember, x goes to -2. This corresponds to the factor x plus 2. Right, everybody? Yes, that corresponds to the factor x plus 2. So, therefore, x plus 2 will go to 0 from the right. If this is from the right, and then this is also from the right. Is that okay, everybody? And then now when you plug in x2 equals -2, you plug it in the factor form. Okay? So here you plug in x. It's a little bit weird here because for the factor x plus 2, you're not really plugging x equals to, you're not doing that, okay? We're not doing x equals -2. It's actually x equals to -2. So x goes to -2 from the right. So this factor will go to 0 plus. But why the other factors we don't do like -2 plus? Okay, the reason is if you plug in -2 plus and -2 and -1, you get like -3. Okay, this notation means we are going to -3 from the right. But for this problem, it does not really matter if it's -3 or -3 to the right, because we just want to know whether this factor is positive or negative. So it does not matter whether it's -3 or it's -2.9 or it's -3.1. Is that okay, everybody? So we are letting x getting close to -2. Yeah, x is not exactly equal to -2. It's a number that close to -2. But because for this factor, we only care about this factor. This number is positive or negative. And so therefore, this will do the same thing as this because both of them are negative. All right. So, okay. Is that okay, everybody? Because they work the same. Therefore, for other factor, let's just make things easy. Let's just plug in x equals -2 to make things easy. So that's why you don't do -2 plus or -2 plus here. Is that clear, everybody? Because whether you are close to -3 or you are a number like close to it, your answer will be the same. Okay? You just need to know this is a negative number. Do you care whether it's -5 or -3 or -10? Does not matter. It's a constant, and this is a negative number. And when you plug in here, this is also a negative number, and this is negative number, and then this is most important. This is 0 plus. So you have constant over 0 plus, Okay, you can multiply by something, it's okay. But it's still like constant over 0 plus. Your answer will be infinity or minus infinity. So is it positive or negative infinity? It depends on the number of negative sign. If you have an even number of negative sign multiplied together, you get positive, right? Negative times negative is positive. If you have an odd number of negative sign multiplied together, you get negative. Okay? So that is why when you let x get close to these points, you just put those power plus minus on those problem factor. Okay, so this is x plus 2 replaced by 0 plus. But the other factors, just plug in negative 2. Is that okay, everybody? Yes. So, for example, like here, when you plug in 1/2 to the right, this because it corresponds to the factor 2x minus 1. So this factor will go to 0 plus. But then the other factors, you just plug in 1/2. Okay? And you don't need to use your calculator to find out what exactly the number is. You just care about whether that number is positive or negative. Okay? So it does not matter whether this is positive 10 or if it's positive 100. Your answer will be the same. Okay? So here you get positive, here you get negative, positive, here you get positive, right? The negative, positive, not positive. That's why here I don't even calculate what that number is. I just want to know whether this factor is negative or positive. So at the end, you count like how many negative, one negative, so negative infinity. Is that okay, everybody? All right. If you have questions.
You didn't get that.
Oh, you're gonna get that. Okay. So let's do more example. Let's do a harder example. Okay. All right. So if you have questions, please come to see me after class, okay? Because in class we might not have like only 15 minutes. So if you have questions, don't wait. Please ask me. Okay. So let's consider the function. Let's make x minus 7. And then 2x plus 3. Here 3x plus 1 square x minus 5 cube. Okay, let's say we have a function like this. Do you see it's already factored? Yes. So this is good, okay? It's already factored. We can go to step 2. Go to step 2. The domain is when the denominator not equal to 0. So that means each factor cannot be 0. Okay, you might ask, we have x minus 7 on the top and on the bottom, right? Can we cancel it? Yes, you can cancel it. But when you compute the domain, you still need to include that. Is that okay, everybody? So what happens? What this will happen is maybe at some point you have like a asymptote, and then this factor means you're gonna have a hole here. Okay? So even though they cancel out, you have a hole there. So you won't have a vertical asymptote there, but you have a hole there. Is that okay, everybody? So you have a missing point there. Okay, so x not equal to what number? How about you guys take turns to answer my questions? Quinton, x not equal to what number? X minus 7 is not 0. So x not equal to 7, right? You add 7 on both sides. And Haley, x not equal to what? Good. Zach, x not equal to? Good. Okay, you see we have 3 numbers. Each number we need to check the left-sided, yes, we let x approaches from the right and approaches from the left. So 2 directions. Okay, let's check. X goes to 7 from the right. And then in this case, this is special. Do you see in our factorization, this x minus 7 cancel out, right? You see it cancel it? So you plus you. So therefore, y equals like 2x plus 3 over 3x plus 1 square x minus 5 cubed. You see, we cancel the x minus 7. So therefore, now when you let x go to 7, you can just plug in 7. X is 7. Is that okay, everybody? Because the x minus 7 factor cancel out. So here we can plug in x equal to 7. So we have what? 2 times 7 plus 3, and then 3 times 7 plus 1 square, and then 7 minus 5 cube. Is that okay, everybody? So for the factor that is not like x minus 7, you can plug in x is 7 there. Okay, everybody? All right, what happened? 2 times 7 is 14 plus 3? 17. And 3 times 7 is 21 plus 1? 22. So 22 squared times 7 minus 5? 2. 2 cubed is 8. Okay. 22 times 2 is like what? 22 times what? 484. Thank you. Yes. How about multiply by 8? You have a calculator? Is a number, okay? 17 over a number. But you see, sorry, what did you say? 3872. Thank you. You see, we actually get a number. We don't go to infinity or minus infinity. Right, everybody? So therefore, 7, x equal to 7 is not a vertical asymptote. So actually, when x goes to 7 from the left, you will get the same answer. So you will have the same answer. Okay? Because it does not have the factor x minus 7. So you won't have 0 plus or 0 minus. Okay, everybody? So you just get a number. So this is what it means. Yeah. When x goes to 7, and this number is just 17 over. So that number is the what? Okay, 17. 3872. Okay. So this is the y coordinate. Okay. So therefore, we have no vertical asymptotes at x equals to 7. Okay, but how about the other 2 points? So the other 2 points, okay, let's say this is the first point, second point. X goes to negative 1/3. Okay, X goes to negative 1/3. That corresponds to which factor? 3x plus 1, right? So, oh, by the way, let's always approach it from the right, and then we change to the left. So this corresponds to 3x plus 1. It goes to 0 from the right. Is that okay, everybody? Yes? Okay. So now what happened to the y? Oh, what do you mean?
So you got 3x plus 1 approaches 0 plus.
Yes.
Why didn't we do x minus 7 approaches 0 plus?
Oh, because it's canceled anyway. So we don't have a chance to because it's in after we cancel it, we don't have this. So we don't need to plug in here. But this part, yeah, it's in the factorization. We plug in here. This is a good point. Everybody, you see? So even though we keep this, they they cancel anyway. So you don't plug in 0, you don't plug in 0. But here, because it's inside, so we need to figure out this is 0 plus or 0 minus. Yes, very good. Okay, so now 2 times x. X is negative 1/3 plus 3. And then, do you see 3x plus 1 goes to 0 plus? And so this is 0 plus square. And then we have the negative 1/3 minus 5 cubed. Is that okay, everybody? We plug in the factor form. Yes. And this factor, we plug in 0 plus. And then the other factor, we plug in x equals negative 1/3. Is that okay, everybody? Okay, tell me, this number is positive or negative? Huh? It's negative? This is negative 2/3. Negative 2/3 and 3, which one is bigger? The 3 is bigger. So this is positive. Right, everybody? Yes. So this is positive. Okay. So you don't need to figure out what exactly the number is. We just care about whether this number is positive or negative. Okay, everybody? Okay, 0 plus square is 0 plus. Okay, so keep in mind, 0 plus square is 0 plus. How about 0 minus square is what? 0 minus square is what? If you have negative number, when you square it, do you get positive number or negative number? Positive. Yes, everybody? Okay, right. So therefore, here is still 0 plus. Okay, tell me, this number is positive or negative? Negative 1/3 and minus 5? Negative. Negative number cubed is what? Negative. Yes, everyone? Okay, negative number cubed is negative. So, what's the answer? What's the answer? Infinity or minus infinity? Yes, minus infinity. Because you have one negative sign. So constant over 0 plus or 0 minus, you get infinity or minus infinity. So it's plus or minus, you count the number of negative sign. Is that okay, everybody? Everybody? Mhm. All right. Now, x goes to negative 1/3 from the left. The 3x plus 1 will go to 0 from the left. What would the y change? Do you see it's the same thing, but we replace 0 plus by 0 minus? What's the difference? You replace 0 plus by 0 minus. That is the only difference. Okay? But what is 0 minus square? Still 0 plus. Oh, you see, we have still 0 plus. So what's the answer? Negative infinity. Same as above. So this is true when your multiplicity is an even number. When your multiplicity is even number, then the two sides they either both go to infinity or both go to minus infinity. Is that okay, everybody? Yes.
I mean, we should just drop this from the exam, honestly.
Can't. Sorry, we can't. And this is only vertical asymptote. And then today we also talk about horizontal asymptote, and we talk about how to graph rational functions. Okay, so this is just one step of the whole process. Okay, so 3, x goes to 5 from the right. Okay, it corresponds to which factor? X minus 5. X minus 5. So x minus 5 will go to 0 plus. Okay, now what happened? You plug in x equals to 5. So what do you get here? 7. You plug in, so what do you write here? X5. X equal to 5. Mm-hmm. Yeah, very good. So we plug in 5. So 2 times 5 plus 3, yes, it's 13. And then the denominator, do you see here? We have 3 times 5 plus 1. Yeah, very good. So 3 times 5 plus 1 is 16. Square it. And now, do you see x minus 5? You plug in x minus 5, replace it by 0 plus. And this is 0 plus, bless you, cube. Okay. Dylan, tell me, this number is positive or negative? Positive. This number is positive or negative? Positive. 0 plus cube is positive or negative? Positive. So we have positive number, and 0 plus. So what's the answer? Positive infinity. Right, everybody? Okay. How about when x goes to 5 from the left? Okay, so 0 plus cube is 0 plus. 0 minus cube, what do you say? Minus. Negative number cube is still negative. Right, everybody? So, what do we change? So x minus 5 goes to 0 minus. The y goes to, so it's almost the same, but we replace 0 plus by 0 minus. So do you see this number is the same as this number? So it's plus, right? And then this number is plus. But 0 minus cube is 0 minus. So what do you say the answer is? Negative infinity. Right. So this means if multiplicity is even, you get the same answer. Okay, everybody? And if the multiplicity is odd, you get your answer is opposite sign. You see the pattern? Okay. So therefore, vertical asymptotes are x equals negative 1/3 and x equals 5. We have two vertical asymptotes. Huh? Oh, because it cancels out. Yeah, it cancels out when you plug it, you just get a number. Okay? When do you have infinity or minus infinity? If you have that factor in the denominator, but not in the numerator, you have constant over 0 plus or 0 minus. That's why you get infinity or minus. Okay, everybody? Okay. Wow, we spent 32 minutes on this problem. Okay, now we we're already one lecture behind schedule. So, okay. So horizontal asymptote. Okay, so we talk about vertical asymptote. Now it's horizontal asymptote. Okay. All right. Horizontal asymptotes. So we look at the your worksheet and then I think the next page, right? Okay, right. Okay. So you have your numerator and denominator. If the degree of the numerator is less than the degree of the denominator, okay, that means your denominator is bigger. Do you agree? The denominator is bigger. Your numerator is smaller, right? So you have a smaller numerator and you have a big denominator. What happened? This goes to 0. Is that okay, everybody? Your denominator is bigger, 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 bigger. That's why these fractions will go to 0. Okay, think about it. 1 over this is going to be what? Very, very small. Okay, you agree? So therefore, if your denominator, the degree is bigger than the numerator, then we will have the y goes to 0. So we will have a horizontal asymptote. Okay, horizontal asymptote equals y equals 0. Okay, and if the degree of the numerator and denominator are the same, so then the y will go to, so you look at the leading coefficient of p and the leading coefficient of q, so y will be the ratio of it. Okay, so you will have a horizontal asymptote. Okay, and if the degree of the numerator is bigger than the degree of the denominator, think about it. Now your numerator is bigger. Your denominator is smaller. Well then, this is either infinity or minus infinity. Do you agree? Yes, everybody? Our numerator, think about it. Our numerator is bigger. Oh, this number is either very big or very small, right? So that's why you get infinity or minus infinity. So in this case, we have no horizontal asymptotes. So this is a picture. If you have a horizontal asymptote, your function is approaching it, right? Getting closer, closer, closer to it. And then here, when you have a horizontal asymptote, and then this is when x goes to minus infinity, the y is approaching to this horizontal line. Is that okay, everybody? All right. So now, how do we solve the problems? So for vertical asymptote, your first step is to factor, right? But for horizontal asymptote, do not factor. Okay? Do not factor. You look at the leading term. So look at the leading term of the numerator and denominator. Okay? Because when x goes to infinity, your leading term dominates the behavior. It's like, okay, you have a million. Do you care about a penny? No, right? So the dominant term, so the leading term dominates the behavior. Okay, everybody? So how do you write it? Okay, so you say when x goes to infinity, your y goes to, look at the leading term. So leading term of numerator over the leading term of the denominator. Okay, tell me, numerator, which one is the leading term? It's the 8x, right? The 8x is the leading term. So just look at the 8x. And the denominator, which one is the leading term? 5x squared. 5x squared. Is that okay, everybody? Yes? Now, you cancel the x. So, what do you get? Yes, 8 over 5x. Now, keep in mind, 1 over infinity is 0. 1 over minus infinity is also 0. When x goes to infinity, 8 over infinity, any constant over infinity is 0. Okay, everybody? Any constant, so not just 1. I should make it simple, so I put 1 here. But any constant over infinity is going to be 0. Is that okay? Mm-hmm. So, yeah, 8 over 5x goes to 0. This step, yeah. We cancel x. Yes, we cancel x. So therefore, x and one of the x cancel. We have 8 over 5x. Now you have constant over something goes to infinity is 0. And now you see when we let x goes to minus infinity, your y, what happened? Your y, you get constant over minus infinity is also 0. Okay, so constant over minus infinity is also 0. So to find horizontal asymptote, you need to check 2 directions, when x goes to infinity and when x goes to minus infinity. You need to check both. But I can tell you, most of the cases, you will have the same answer. Okay? So, yes. You might expect like different horizontal asymptote for some type of functions, but that one is harder. We're not going to talk about it in our course. Yes. We don't change anything because constants over minus infinity is always 0. So constant over infinity is 0. Constant over minus infinity is also 0. So that's why no. Yeah. Okay. So therefore, we say horizontal asymptote is y equals 0. So horizontal asymptote is horizontal line. Okay. All right. So this is part A. How about part B? Okay, part B. You do the same thing. Bless you. You let x goes to infinity. Y goes to. Can you tell me the leading term of the numerator? Let's see, Dylan, what's the leading term of the numerator? Yeah. And how about the leading term of the denominator? Yes. Oh, what happened? X squared cancel. We get 3 over 2. Ooh, you see? We're approaching the line y equals 3 over 2. Also, when x goes to minus infinity, what happens? Your y goes to the same thing. Right? You see this process? It does not matter x is positive or x is negative. It cancel anyway. Right? So, oh yeah, and that's it. We say the horizontal asymptote is y equals 3 half. Question.
So if it doesn't matter, what's the point of doing the infinity and the negative infinity?
It does not matter for this problem. But
okay.
if you have other problems, it will matter. But because we don't have enough time now, we don't cover those other problems.
There's harder problems?
No, yeah, they're using harder problems. If you want to know, come to my office. I can show you the harder problems. When you go to two different directions, you will have different horizontal asymptotes. But it's so useful. You will use it a lot in your major and everyday life. Okay. Yeah, it's just in this case, if we have rational function, your two sides, two directions will have the same answer. Just for this side. Okay. All right. So keep going. But do you see, like this example is much easier than the vertical asymptote problems, right? You just look at the denominator terms, and then boom, you get the number, right? Okay. When x goes to infinity, what happened to your y? Alice, what's the leading term of the numerator? 6x cubed, right? How about the leading term of the denominator? Yes. Oh, what can you cancel? Yes. Do you see we have 6x over 11? Oh, okay, David. This part is good because you can see the difference. You see when x goes to infinity, you get infinity over a number. It's infinity, right? So this is infinity, but when x goes to minus infinity, what happens? The Now the x is minus infinity. So minus infinity over a positive number, you
Okay,
get.
so it only doesn't matter if the numerator is larger than the denominator.
Yes, that will matter, right? Okay. And if you get infinity or minus infinity, that means we do not have a horizontal asymptote.
Wait, why does it change?
Oh, because this the x goes to infinity. And so 6 and 11, they are positive numbers. So that's why you get infinity.
So what about the first one then?
The first one, oh, because the infinity is in the denominator.
It's in the denominator. Oh, okay.
Yes, right.
So,
Yeah.
so if there's an x, if the x's don't cancel out, will be infinity and negative, as long as it's in the
Yes, exactly. Yes. This one? Because the x goes to minus infinity, and 6 and 11 are positive numbers. So you get negative. Yes. Mm-hmm. Right.
So then what would it be if the numerator and the denominator don't cancel out?
Don't cancel out.
Yeah, so
So okay, here are the three cases. Here, your denominator is bigger.
oh, so those are the only three options for horizontal asymptotes?
Yes.
Yeah, okay.
For rational functions, only three options. The denominator is bigger, or they are the same size, so you have the same degree, or the numerator is bigger. Right? And that's always the case. You only have these three cases. Okay? Any questions about horizontal asymptote?
Either right or vertical.
Yes, exactly. You just because you don't need to factor, just look at the dominant term. Okay. Let's see. All right. So please do those exercises at home. Okay. Math is really a lot of exercise. Okay. All right. Now comes the hard part. I agree with you. I would say this problem probably is the hardest problem and longest problem in your exam 3.
Oh, so you're saying this exact problem's on our exam?
Huh?
Are you saying that problem's on our exam?
Not exact problem, but similar. Yeah.
Similar.
Yes. On exam 3.
So it's going to be just as long and just as difficult.
Yes. Great. Okay. Now, how to graph rational functions. Step 1. Factor the numerator and denominator. That is step 1. Factor the numerator and denominator. Find the x-intercept. What's the x-intercept? How do you find x-intercept? So to find x-intercept, you set the numerator equal to 0 and you solve for x. Is that okay, everybody? Yeah, put it down on your notes. How do we find x-intercept? You set the numerator equal to 0 and you solve for x. Okay, and then y-intercept. Y-intercept. Evaluate f of 0. So that is how you find the y-intercept. Remember the x-intercept, you set the y equal to 0, you solve for x. And then the y-intercept, you set the x equal to 0 and you solve for y. Okay? So this is how we find x-intercept and y-intercept. Now, vertical asymptote. Right? Vertical asymptote, you set the denominator equal to 0 and you get some x values. Let's say it's a. And then you want to check what happens if x goes to a from the right and from the left. And then you ask, does your y go to infinity or minus infinity? That is the vertical asymptote. Okay, so what we did is only one step of this process. Okay, and then horizontal asymptote, what do we do? Don't look at the factor form, okay? We look at the leading term of numerator over the leading term of the denominator. Okay, and you are letting x, so you're letting x goes to infinity or x goes to minus infinity. And then you want to figure out what happened to your y. Okay? If y goes to a number, then you have a horizontal asymptote. If y goes to infinity or minus infinity, then we don't have horizontal asymptote. And then step 5, graph. Plot the x-intercept and y-intercept, okay? And then draw those vertical asymptote and horizontal asymptote. Oh, we don't have time to talk about this example yet. Okay, we continue on Monday. I really hope that our class is double class. So we can do more examples and do it slowly. Okay, so please complete your practice exams and come to see me today and next week. Okay, bye.